Let's do a good test level problem, huh? A little test level problem. See how your teacher would ask you something. So let R be the region bounded by y is equal to negative x squared plus 4x plus 2, that parabola facing down. And y equals x squared minus 6x plus 10, a parabola facing up. Determine the volume of the region R revolved about the y-axis. And we're going to use shells, okay? You would have no choice in this matter. You would be forced into using shells unless you got some skills that your teacher doesn't possess, but this is pretty much not much we can do. So it's going to kind of quick sketch it. Do this one in blue. I know it's some sort of parabola facing down. I don't know, maybe it's here. I'm assuming it is. And then we have some sort of parabola that's facing up. And we're going to have some region R right here in the center. Full disclosure, I don't know what the freaking things look like, but I know that there's some sort of parabola facing up and some sort of parabola facing down. So that means we're going to have two different functions. So since we're going about the y-axis, we know that our formula, our volume, is going to be 2 pi from A to B of x times, and now since we have two different functions, we have to have some f of x minus some g of x dx. So why don't we call f of x the top function, that parabola that's facing down, and we'll call g of x the parabola that's facing up. No, the parabola facing up has got to be on the bottom, and the parabola facing down has got to be on top. I mean, there's not going to be any frickin' region for us to evaluate. And who knows? Maybe these values are over on the left-hand side of the y-axis. I don't frickin' know. It doesn't really matter. We just have to figure out the a and the b. All we need that thing to be is on top of the x-axis. All right, cool. Cool. Well, let's go get our f of x minus g of x. The stuff's already set up. Look at this. F of x minus g of x. So let's, oh no, we have to subtract them. Oh man, so I was hoping we could just add them, but no, so that's going to become negative 2x squared. Remember, we're subtracting, so we're going to change all the signs. Then we're going to get plus 10x, and then we're subtracting, so we get minus 8. All right, so our volume is 2 pi, the integral of x times negative 2x squared plus 10x minus 8 dx. But we still need to figure out where those points of intersection are. We need to know where the A is, and we need to know where the B is. Is anybody just sitting there going like, oh, clearly, 1 and 4. It's just 1 and 4. I got that, dude. I got that. I don't. So what we're going to do is we have to set them equal to each other. Take our f of x. And so set this thing equal to our g of x, which was positive x squared minus 6x plus 10. And then we're going to go through, we need to solve. So let's move everything over to the right-hand side because we don't want negatives, we want positives. So add the x squared over, we get 2x squared. Huh, this feels familiar. Minus 4x minus 6x, that's minus 10. Wait a second. I'm going to guess this is an 8, but with a different sign. Hey, there it is. Our f of x minus g of x is going to tell us what to set equal to 0 so we can, their point of intersection when the distance between the two gosh darn things is 0. Huh. So let's factor out that 2. Let's get rid of that bad boy. Oh, it's going to pop. It's going to pop right there. Divide out the 2. We get x minus 4, x minus 1. Therefore, x is equal to 4, or x is equal to 1. There's our frickin' bounds, 1 to 4. Dude, there's 90% of our problem done. If this was something on a test, this might actually be a really good problem for me to ask you to just, hey, set it up. Just set it up. And that would be the solution right there, with our bounds plugged in. Having to find the difference between the upper and the lower for our f of x minus g of x. Multiply that by x. Then take the integral from a to b. That means 1 to 4. And then don't forget to multiply by 2 pi, and you got the gosh darn thing. Patterns. Start recognizing patterns. But let's continue on. Let's solve this one. And let's see what sort of area we're going to, or what kind of volume we're going to get. So it's 2 pi from 1 to 4. Let's distribute. So negative 2x cubed plus 10x squared minus 8x dx. Oh man, this might get gross. I have a funny feeling it's going to get terrible. So we're going to add 1 to this exponent. We're going to get 4, and then we're going to divide by that. Negative 2 divided by 4 is negative 1/2. We're going to add 3 to this exponent, so we're going to get 10 thirds. Oh, golly. Now we're going to add 1 to that exponent. It's going to become, what, 4x squared? We're going from 1 to 4. Oh, man. Oh, these numbers are going to get terrible. Oh, well, we can deal with it. So we have 2 pi. We got negative 1/2, 4 to the 4th, plus 10 over 3, 4 to the 3rd. I imagine a lot of y'all are going to check out now. You're like, I don't care to watch you do algebra. Or, oh, I'm sorry, arithmetic. And then we get negative 1/2 plus 10 thirds minus 4. All right, you just ignore the x's and just plug them all in. All right, 2 pi. So what do we got? 4 to the 4th. 4 cubed is 64. 64 times 4 is 256. Half of 256 is negative 128. Oh, now we have 4 cubed. That's 64. 64 times 10 is 640 all over 3. I don't like this problem. Minus, oh, geez, 64. Minus, and we got to put all this crap together. What is that? Let's just get it done. Oh, plus 10 over 3 minus 4. So I think we're going to use, what's that? 6's. So 6 down at the bottom. So that's negative 3 plus 20 minus, 4 times 6 is 24. So where's that? Negative 7/6. All right. Got that. I know I'm going to make a mistake in here. I know I'm going to. I know it's going to happen. No attention to detail. Now I've got to play the same game. We've got to create a 3 down in this denominator. Oh, golly. I've got to create a 3 down here. So 3 times 128. I'm not pulling my calculator out. You are. It's negative 384 plus 640. And now we got to 64 times 3. And that's going to be negative 192. Oops. Plus our 7/6. So 640 minus 384 minus 192. Yeah, 64. Gosh darn, 64 keeps popping up. So we got 64 over 3 plus 7 over 6. One more freaking common denominator. So it's 128 plus 7. It's going to create a pi times something over 3. 128 plus 7, 135. Oh my goodness, we got the gosh darn answer. And it was positive. So at least we didn't do something horribly wrong. So how was that? Oh my goodness. Do you see why maybe on a test it might be in my best interest to just ask you all to set it up? Because if you set it up, you've done the hard part. What? Just not the tedious part. Because something like this can take you freaking 15 minutes sometimes. You go the wrong direction. You see all the fractions after you get past your part, and then you got to start doing it. You might make a mistake. You heard me whining and crying the whole way through. So maybe we just set them up when they're this tedious. So we want to really work on this. Going back to it. We see that we're revolved about the y-axis. Everything's in terms of x's. It means you're using shells. So we use our formula. We run it through. We got to get our bounds. Sometimes the bounds is the tough part. But I think this is a good spot to stop in this problem. And then we're going to start putting it all together next. So I haven't done it yet. We need to revolve about another number, not an axis. Maybe x equals 4. Maybe y equals negative 3. And we're going to start mixing up our discs and washers with our shell method. And we'll see when and where to use them. All right, see you in the next.